So this is the second recording on the sparse array, and I just want to recap. We have two classes as a part of this sparse array. The first being sparse array entry. So we'll have multiple entries or elements or items, however you want to look at it, in the sparse array itself. So each entry has the characteristics shown, row, column, and value. Now, we are going to visualize this as a 2D array, but in memory it is not really a two-dimensional array. And we'll see that when we try to go through it and we realize we can't just do sparse array bracket, 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 bracket with row and column numbers in it to get our values. And then here we have the sparse array. So this thing is going to hold multiple sparse array entries, multiple row column value combinations here. And so the instance variable here are the number of rows, the number of columns. And notice here, and I talked about in the other lecture, we have a collection, which is a parent, a generic class, then list is a child of that and has some of its own characteristics that it passes on to one of its children, which is array list. Now, list is an interface, and I believe we'll get to that in chapter 9, so that'll be coming up quickly. Interfaces are an abstraction, they're abstract, and you'll see what I mean when we get to that, like they don't have constructors, for example. So when you see private list and it is of type sparse array entry, you could have a list of, strings, whatever. So this is your typical bracket with the data type. In this case, this is going to be a collection of sparse array entries. It's going to be named entries, and then notice here it's new array list. Okay, so it's private list, the data type, the name equals new array list. Now, I want to just point out, you cannot do this. You cannot do list and what did they call that? Sparse array entries. And they called it entries. You cannot do this. This will not work. Because list is abstract. So if you try to ever do something like that in the compiler, you might think you could do that. You can't, because list is an interface. You'll get back a compile message that says list is abstract. It cannot be instantiated. You cannot create a list object in this manner. So what you have to do is use a real thing, an array list, for example, when you're doing a list. There are several types of lists, so that I think vector is a type of list. So there are a couple of words you can use here, but as far as the AP exam is concerned, we're just going to worry about lists when we get to chapter 9, interfaces, and array lists as one way to implement a list or collection is through an array list. So this is why they have used this statement. This is the only way you can take the list interface and actually create something concrete, an array list with it. Array list is a child of list, and so this is allowed, that you can do list, data type, entries equals new array list. And so we have some different methods here, and I think in the earlier lecture I've said now this is a visualization for you, but in memory it's not stored like this, because remember, array lists are not two-dimensional. In memory, we have kind of this linear list of sparse array entries with the 3 instance variables in them. And we only populate rows and columns where there's a value. If there's not an entry, say for row 0, column 0, there's no entry in the entries sparse array list, so we know that it would be a 0. So when we look at the answer for section A here, we've got get value out, which they tell us, they give us this header line here, and we've got to make the method work. So we're going to iterate over the sparse array using an enhanced for loop because it is an array list, so we can do that. And of course, entries is the actual array list. We are referencing it with the name entry here in the enhanced for loop. So we're going to use the get row and get column methods of the sparse array entry class. And what we're going to do is we're going to say, as it's going through this list here, it's going to come to the first one, and we're using a getter because, again, this really is not a two-dimensional array in memory. It is just an object with 3 instance variables. So we have to use our getter get row to check the row value. Then we use our getter get call and see if the row and the column for this first one matches the row column combination that was entered. And if so, we use the getter method from the sparse array entry class to get the value of 4 returned. Now if we get to this line here, we return a 4, for example, if we're doing row 1, column 4, we return the value 4, and then the method stops, okay? The return stops it so it never gets to the return 0, and we go back to main where we're calling this from, for example, and we move on. If we never find the row column combination, so if it was row 0, column 0, that is not in this entries list, so we would never get to this statement. So what would happen was, after the for loop finished, it would drop through to this return 0 and send that back, and that's how we would flag ourselves that we had a 0 entry. So notice we're not able to do like entry bracket, row bracket, bracket call bracket, because it's not really a two-dimensional array. We have to use the getters and the setters from that class to see if we have the right row and column combination, and then we grab the value back. So if we entered 3 and 1, it would check, it would be iterating through, and it would say, okay, 1 and 4, that's not the same as 3 and 1, move to the next one. 2, 0, that's not the same as 3 and 1. Oh look, here I am, 3, 1, return -9, and then it would stop. So that is the answer to this one, to the first part. So now we're going to go to the remove column, which they give us this header line. It's not going to return anything, but it's going to take in the column number. Now you have to be careful, and we'll see this as we learn more about lists. You cannot use that enhanced for loop with a list. Remember, we had list bracket, angle bracket, sparse array, entry angle bracket. So this is a list, and we cannot use a enhanced for loop to manipulate, to remove columns. We can use the enhanced for loop to go through the values and print them out. But when we start manipulating the values in the list, we have to use either an iterator, which we have not covered yet, we will cover later, or we can use a traditional for loop. We cannot use the enhanced for loop. So we're going to go from the end to the beginning on this thing, and we're going to pass in the column. And we are going to, again, we're going to have a temporary local variable here that is of type sparse array entry. We're going to go to the entries list, array list that we've set up. We're going to use the get method to bring back for the first, well, we're starting at the end, so we would be getting this unit, this object back. And we would be getting back into entry. Entry is now an object that has a row, column, and value of 1, 1, and 5. So we're going to do that here as we're looping from the end to the beginning. We're going to grab this one at the end. Now we're going to check the column number using the getter in the sparse array entry class, and we're going to say that we wanted to remove column 0. So we're going to compare, right, is the column number of this entry, which is a 1, equal to column 0? No, it's not. So we're not going to do any remove. Now we're going to say, okay, so this one wasn't true, so now let's drop through to the else if. Is the column greater than, the column that we're on greater than the number of the column we want to delete? Yes, it would be. And we've got to talk about how we would actually remove that column. So regardless, we're removing a column, and the precondition and postcondition specified that the column had to exist. We're not allowed to enter like a -1 for column or a 1,000,000 for column. The column has to exist. That's the precondition, the requirement before this method could ever execute. So we're safe outside of the for loop when we're done with all the housekeeping of taking values out and shifting columns. We can come outside of all that logic, and as the last line of code, we can subtract 1 from the instance variable num calls, which, if you'll remember, is in that sparse entry, that second class, okay? And that's how we can remove 1 from the total column count. It's not dependent on any of this code. It's going to happen regardless because the precondition says you had to have entered a real column to begin with. So the question becomes now, what is the code that would actually, let's talk about, before I do that, when we get to the column. So I want to delete column 0 here, or column 1. So this is column, in effect, this is the 0 element, this is the first element, right, in this array. So index of 0, index of 1. If I pass in a 1 here, when I go through, when that for loop finally gets here, and the column of 0, oh, sorry guys, I'm totally losing my train of thought here. I apologize for that. So what I'm doing is I'm saying I want to delete column 1, right? So I'm going to be not worrying about the index numbers of these individual things. I'm worrying about the column, the column that is specified. Where am I? I'm worrying about the column that is specified here as the instance variable. So as I'm going through, if I say, for example, let's just change, I want to delete column 0. Okay, so this one, the column is 1. I don't remove it. I have to still figure out how I'm going to shift it because I am deleting a column. Same thing with this one. When I get to this one, the column number is 0, and I can use entries dot remove I, because I is the actual index of this one in the entries array, the one that I'm on. So it will, that dot remove method will pull it out. So all that leaves us with is trying to figure out how we're actually going to shift the columns, the entries that have a column of 1, or for example column of 4. All of those are shifting down 1 if we delete column 0. So how are we going to do that? That's the next question.